Hello, my name is Anshuman Pandey, and I'm a script encoder. But that's my secret life. I work for a fintech in Chicago called Avant, where I do analytics and data engineering. And before that, I earned a PhD in history at the University of Michigan, where I studied not writing systems, but social organization and linguistic anthropology. So this has always been, but I've been loving and working on scripts since I was 13 years old, and so this is what I do for a quote-unquote non-living. Okay. So the encoding of any character in Unicode is the final step in a long research journey. That step is also where research begins anew. So my journey thus far. In 19 years, I've worked on 30 scripts, 28 of which have been encoded, 2 are pending. There are 4 number systems, 35 individual characters, and 4 emoji. In the next mile, which I probably 5 more years, 18 more scripts, 2 script supplements, and 1 number system. So a lot of scripts that we discussed today, linear Elamite, proto-Elamite, they're actively being worked on. And the way that this chart is set up is it shows the first point at which a script was added to the Unicode roadmap. The red means that it's been added to the roadmap. Blue means that there's a document for that script. Green means that it's been approved. And the gray extending all the way to the right shows that it's been encoded and continues to be in the standard. Now, you see that some of these scripts that are yet to be encoded have been on the roadmap for quite some time, and some are fairly new. And once we get past these 18 scripts, there are some others additional, 22 more scripts at least, and 1 number system that I have documented. Others are working on these problems, these issues, and within the rest of the purview of unencoded scripts, hopefully, as Johannes mentioned, by 2047, we'll get through all of them. Now, the people who have helped me along this journey, the trailblazers, in fact, like Deborah Anderson from SEI, and also folks on the script ad hoc, chaired by Debbie and also by Rusbe, with a lot of contributions from Ben and from Manish, who spoke earlier. And I'm really happy that some of the scripts that I've already encoded, Devesa Kuru, will be covered here by Fernando tomorrow, and also Proto-Elamite and Linear Elamite by Kaveh and by Sina also tomorrow. So why do any of this work? Well, for me, I want to ensure that the digital input, display, and interchange of all text in every script ever created is as digitally native as the English text you are now reading. And this is how I interact with scripts. Device in hand, looking at a screen, trying to make sense of what this shape represents. And there's beings on the other side with who I'm trying to communicate using this digital screen. In case you don't know, this is a still from the movie Arrival, based on a story called The Story of Your Life by Ian Chang. So with that in mind, we've talked about scripts since this morning. Now I want to talk about character. So according to Unicode, a character is the smallest component of written language that has semantic value. It has its abstract meaning and shape rather than a specific shape of a sign. So for example, we define the Latin letter A, and as Manish and Ben has shown earlier, it has different glyphic representations. But underlying platonically, it is the letter A. Now, also a character here is also a unit of information used for the organization, control, or representation of textual data. Simplistically, it's the basic unit of a script or writing system. For example, here are 5 letters, 5 characters for the Latin alphabet, and 5 characters for the Devanagari alpha syllabary. Also, character is whatever the Unicode Tech Committee wants it to be. There is no firm definition for it. So now characters count, or character counts. There's, as Johannes mentioned, 161 scripts already encoded with almost 150,000 characters in the standard. However, in many cases, there are still missing characters for encoded scripts. These are characters that are newly encoded or newly created for minority languages. They may be historical or archaic characters that are no longer used, or specialized characters. And very simply, characters that have gone unnoticed until now. But in any case, the absence of these characters from Unicode prevent full representation of information in digital text. So let's talk about Devanagari, very ubiquitous writing system of the world. I know this is a very boring script to talk about. It's been overdone, but I bring it up for a reason. It has 700 million users. It's used for writing Hindi, Marathi, Nepali, a host of other languages throughout India and Nepal. It's regulated by standards within India and also Nepal, such as ISKI. And it was added to Unicode, sorry, this should be version 1. And since its presence in Unicode, Devanagari has had a really forceful influence on the encoding of all other Indic scripts and alpha syllabaries. So what you see is when Unicode first encoded Devanagari, this is a chart from version 4, it added a new character. It had overlooked one. And over time, since then, we have filled the entire basic code block for Devanagari with additional characters used for both historical and for minority languages. However, we kept finding more. We needed to support the representation of the Vedic texts, which are very important to the Hindi universe. We added additional characters for Devanagari itself, and then most recently, we had to add another block for Devanagari called Devanagari Extended A. So the 7 steps, I'm going to focus on that last block, Devanagari Extended A. And the steps that I will go through are how to identify when a character is missing or if we need to add a character, how to evaluate the suitability of encoding that character in Unicode, the normalization process of taking text from the wild and digitizing it, and then modeling that character for encoding in Unicode, coming up with the design for it, validating that design, finally proposing it, and then going back to identify. One point I want to make here, because Professor Knuth is in the audience, I've written over 300 documents for Unicode, and they've all been written in LaTeX. So without your work, I would not have been able to do mine. More importantly, every single font that I've designed for these code charts has all been done in Metafont. Most recently, I started using FontForge, but I started off using parametric font design. And so thank you for Metafont as well. So the 7 steps of character encoding, the story of O. So one day I'm browsing, Janepedia, as we normally do on a given afternoon. I came across this definition of a word called bhale. It's an auspicious symbol known as bhale and transliterated as this sequence of characters. And I was trying to figure out what are they referring to here. So as an historian, I went and tried to find a catalog of Jain manuscripts and found a description of this sign called bhale, and a nice description here, but no real evidence for what that character actually looks like. And again, Tripathi closes out his little paragraph and says, we produce this as a section mark O. So now we know where Janepedia got their transliteration scheme from. So being an historian, my job is to say, okay, let's look at the Unicode code charts. Do we have this character somewhere within Unicode? And it turns out that we did not. So doing some more research, digging, found an article published about this very symbol itself by Bhattacharya about 23 years ago. And in his description, he offers a handwritten diagram that finally shows me what the shape of this symbol is. And he remarks, he says, it's very unfortunate that the European scholars have completely ignored a symbol invariably employed by the Indian scribe at the beginning of a manuscript. Surely they were sure of the significance of this symbol. So what this shows is that it's a very meaningful symbol, but there's very little information about it, even by European scholars who were very, very diligent about studying documents or Indian manuscripts. So now we go back to Weber, and we can trace back and say, okay, where does this symbol come from? Okay, Weber tells us that, okay, this is what it looks like. So moving on from identify to evaluate, let's go look at Jain manuscripts, and we can find one and say, okay, that's what the symbol is at the beginning of the manuscript. Now we have a shape that looks very similar to what Weber described, but we found another manuscript that looks just a little different than what we saw over here, and so on, and so on, and so forth. And we see more variations. And we see characters that appear in that Jain diagram, but are not very similar to what we've seen before. So now we get through evaluation and say, okay, we have so many different versions of this symbol. What do we do? Like, how do we make sense of this? And were we to encode this, what would we do? So the first step is to normalize, to get a basis for what the actual handwritten signs might look like. So this is my attempt at normalizing all of these scribal inputs. And then we come up with the model. So do we encode each of these as an atomic character within Unicode? Or do we consider them to be variants of a single character? So we go through the process. We look at the whole model, at the whole diagram, character by character, or element by element. We see that there's a pattern here. The symbol has a beginning. It begins with a certain type of character. Then we go to the middle. There's a certain sequence here of character A and character B. And then we can distinguish. Character A and character B have very similar patterns, except for, in some cases, where there's some graphical variation for the blue character, character B. And then we look at the end. The end, also similar. It ends with a very standard or very uniform close. So now we can break this apart. We say we have a boundary on both sides. We have a head mark. And within the head mark are a core and another core. So then we get to the point where we say, okay, we got to give these things names. If we want to encode them in Unicode, we have to give them names. So we can come up with names. We run them by Manish and we run them by Ben. They give us feedback. We go back and forth, we iterate, and say, okay, this is a set of characters that we could use to represent the symbol. Then we actually design, we draw, we test, we see what works, and then we validate. We go back to primary sources, back to secondary sources. We try to find descriptions of what we're trying to encode, and we try to find if there's additional characters that we have missed at this point. So then we propose, and then we encode. But how did I even get to this ballet sign in the first place? I discovered it when I was trying to identify what the previous symbol was. That's called the Devanagari Swasti symbol. It's also an auspicious symbol, just like ballet is. Before that, I was working on characters that were used in Eastern Indic religious poetry. Before that, I was working on another Jain manuscript where I found a Jain Om. And before that, another character that was used in Jane documents. But following Bulle, what's going to come next? Could be another character. But this shows that the process of encoding characters for something like even Devanagari is not yet complete, because there are at least 35 other characters that are going to go into the Devanagari extended A that I have proposals in the works for. So when we identify, evaluate, normalize, model, design, validate, propose, we are getting to a point where we're standardizing. And within the INDIC concept, within the INDIC worldview, there is a concept called saptapad, which means 7-step. Saptapad means ratified, or synonymously, encoded. Now, if we were to take this concept of 7 steps, and let's say translate it to a different language, like Greek, we would get heptapod. Actually, heptapod B. Heptapod A is a spoken language. So how do we identify? Well, it's there on the screen. We evaluate. And then we go through the process. Thankfully, Wolfram Research, the folks who actually designed this, have a GitHub repo that has this set of characters. But at some point in the future, I do want to encode heptapod B. And that's where research begins. Thank you.